You are welcome to Tutorials with Fermenting the Schoolboy. Today we are going to take a look at chemistry. To review our assignment on chemistry on the topic solubility. So I don't know. Let's hear the question we have for today. Question number, how many questions we are given? Two. Oh yeah, call the questions. Come out, Chinwe. Let's start from you. Come out, fast. No time. Come out. You don't solve it. Why?
I cannot solve it.
Okay, you cannot solve it. Any of them?
No, I can solve the second one.
Did you solve your own? Huh? Try. Okay, Chinwe, go and solve the one you can solve. Let's take it up from there. Come and start with the one you can solve. Call the question first. Louder, please.
If 24.4 grams of lead trioxonitrate 5 were dissolved in 42 grams of distilled water at 20 degrees Celsius, calculate the solubility of the solute in gram per dm cube.
Okay. Okay, explain what you did.
They said that we should calculate the solubility of the solute in gram per dm cube, which is, and the solute is lead trioxonitrate 5. Then 1 gram is 1 centimeter cube. Then how
For what? For what? 1 gram of what?
Of water is 1 centimeter cube. Then 42 grams of water, we don't know what it is. Then we cross multiply. Is now 42 grams times 1 cm cube divided by 1 gram. Gram will cancel gram. Now left with 42 times 1 centimeter cube, which is 42 centimeter cube. Then we convert this 42 centimeter cube to dm cube, that is volume. Then 1 dm cube is equal to 1000 cm cube. Then 42 cm cube, we don't know what it is, we put it as x. Then we now cross multiply. We now have 42 cm cube times 1 dm cube divided by 1000 cm cube. Cm cube will cancel cm cube. We are now left with 42 times 1 dm cube divided by 1000, which is equal to 0.042 dm cube. So the answer is to calculate the solubility of the solute in gram per dm. Then 24.4 grams of lead trioxonitrate 5 divided by 0.042 dm cube. Now 508.95 grams per dm cube. Then if we now approximate this
95.
This 95. Now if you approximate this one, 9, here is 10. You approximate this is up to 5. Then you approximate it becomes 1. So it's now 581.00 gram per dm cube.
Do you understand what you did? Is that what you solved? Huh? Okay, but you should remember if you solved it now. Is that what you solved? Huh? You forgotten what you solved? So how come you forgot what you solved with your own hands? Does it make sense? Do you have issue with this question, this topic? But we will soon leave solubility. That's why I'm asking if you have issue there. All right. So, okay, call the second question. Let's look at it. You said you could not solve the second question. Call it. Let's see. Wait. Let me clean the board. Don't worry. By the time I solve it, you know whether you got it or not. So that's why it's good to do assignments. Please, if you are given an assignment, try to do it, because even if you did not get it, by virtue of you are doing it, when we are doing correction here, you now try, you not understand it by comparison. You're not comparing what you did and what you are doing. It will internalize more. It will internalize. All right, please, louder. The question. Okay, the diagram. Okay, give me that. Let me draw the diagram. So I can capture your voice. Call the question. Be louder.
From the diagram above, find the amount of solute deposited when 200 centimeter cube of the solution is cooled from 55 degrees Celsius to 40 degrees Celsius.
Again, call it again.
From the diagram above, find the amount of solute deposited when 200 centimeter cube of the solution is cooled from 55 degrees Celsius to 40 degrees Celsius.
All right, thank you. Now listen. Remember what we said about the effect of temperature on solubility, right? As temperature increases, what happens to solubility? As it decreases, what happens to solubility? Temperature will do what? Decrease. As the temperature decreases, solubility will do what? Decrease. That means the solid will do what? Precipitate out, right? The crystals of the solid will do what? Precipitate out as the temperature goes down. Now look at this diagram. On this y axis, vertical axis, this is y axis or vertical axis. We have number of moles of what? Solute. On the x axis or the horizontal axis, we have the what? Temperature. And the temperature scale, we have 10 degrees Celsius. The unit here is the unit of temperature here is what? Degree what? Celsius. Y here is what? Moles. Are we together? Now we have 10, 20, 30, 40, 50, and 60 what? Degrees what? Celsius. So that means this is temperature. Now here we have 2 moles. The line, this curve, cuts the x-axis, y-axis between 2 and what? 4. Which we can take it as a what? The middle, right? If this is 2, this is 4, this should be around what? 3, right? Let's keep it at that. Now, but we are told that if we cool this thing from 55 degrees Celsius to 40, that means if it cools from here, this is 50, this is 60, so 55 should lie between what? 50 and what? 60, so 55 should be somewhere here, right? So if it cools from here to 40, if it cools from here to 40, let's see the change it will make here. Let's see the change it will do what? Make here. Let's trace from 50, 55, right? Let's trace from, even though this will not give you a perfect distance because it's not a graph, but let's just see what you can achieve with it. If this is traced like this, if you trace this like this in a straight line, we'll trace it, right? And come here, right? Then we'll trace 440 like this and do what? Come here. From here in a straight line, we'll trace it back to here, right? If you trace it back to here, even though this scale is wrong, but let's just try. If you scale it like this, this story was let me look for the correct past question. Let's see if you can trace it from the past. I'll teach you how to do this tracing. But let me just do it rough here. Because this cannot be what the correct answer. You know why? There's no scale here. But let me just teach you how to do it first. Then after we solve it here, then use the one in the past question, the exact diagram, and trace it on diagrams and see what we can get. Is it clear? Now the way to do this now, you trace this one to this place, right? If you trace it now, you will get to what here? Get what? 10, right? Right? If you trace it now, you will get what? Call it 10. Okay? Then we'll trace the 40 degrees Celsius. If you trace it, Call it 7. Okay? If you trace from here, 40, at a point where 40 touches this curve, or this straight line, this straight line graph, as at this point now, when it's at this point, I will trace it back to what? The mole. Here is how many moles? 7 what? Moles. Here is how many moles? 10 moles. Now, what it means is this: as temperature move from 55 degrees Celsius to 40 degrees Celsius, the number of moles that will precipitate out is what? This 10 minus what? 7 moles, which is what? 3 moles. What this thing means is that as temperature cools from here 55 degrees Celsius to 40 degrees Celsius, number of moles of the solid that will precipitate us, the crystal that will precipitate us is what? This 10 degrees Celsius, this 10 moles minus what? 7 moles. The same thing we have 55 degrees Celsius minus what? 40 degrees Celsius. This will got 10 moles minus what? 7 moles, which is what? 3 moles. So 3 moles will do what? Are you following? 3 moles will do what? Precipitate out. So the number of crystals, the number of moles of the solute crystal. See what? And I'm just writing what I'm saying now. Just follow what I'm saying. What I'm writing is what I'm just saying now. I said that the number of this marker is not what I want to say. Let me look at that marker. The number of moles, can you see it now? The number of moles of solid crystal that precipitates out when the solution is cooled from 55 degrees Celsius to 40 degrees Celsius is equal to what? 10 what? Moles minus what? 7 moles, which is what? 3 what? Moles. Is it clear? Now, but what the question say?
That we should find the amount of solutes deposited when 200 centimeter cube of the solution is cooled from 55 degrees Celsius to 40 degrees Celsius.
It's cooled from where? 55 degrees Celsius to what? 40 degrees Celsius. Is it the amount we are trying to find?
Yes.
That will do what?
That we should find the amount of solutes deposited when 200 centimeter cube of the solution is cooled from 55 degrees Celsius to 40 degrees Celsius.
Amount, whether it's in gram or mole.
No. But the options is in mole.
You know, this scale is not that wonderful. But what I can get from using this scale is 3 moles. Using this scale, but if I look at the diagram, I may get something else. Let's look at the diagram and see where, we believe that the comparison may be to scales. Is this 3 moles in the option?
No. 0.10, 0.20, 0.0.
Okay. Now, see what you do. They told us, they gave us a particular word, volume. Okay, now, they gave us a volume now. We'll find the what? There's nothing we are finding without getting the proper diagram. We keep having an issue if you don't have the proper diagram. I will trace the proper diagram so I don't waste my time here. Let me trace the proper diagram. Okay, see it here. Let's do it together. Come closer. Come closer. Let me see. See the proper diagram. Here is what? Get pen. Did you have a ruler there? Let's see what you can make out of this place. This is 2. Have you seen that this end at where?
8.
Where do you think we can trace into?
7.
It's 7. 8 is here. You see it? It's between 6 and 8. That means here is what? 7. But what you are looking for, 55 is what? Between 50 and 60, right? So if you trace this half now, let's trace it. I don't mean that there's ruler here, it would have been better, but let's see what you can get. If you trace 55 here, you cut it here. And if you trace
4.
If you trace here now, you get what?
5.
Let me see. If you trace here now, it's 6, right?
It's 5.
Is it 6 or 5?
5.
No.
Is that what?
No, 5.
Hey, I wish I can get ruler here now. We cannot solve this because of what we tell you. And how get your pen. Let's see what you can make with your pen. If you trace here now, here 6. Can you see it? Can you see it? Eh? It's 6. It's not 5. It's 6. It's what? 6. Now from 55 to 6. Now let's look at 40. This is 40, right? This is where it should be, right? Even this itself is not straight. This 90 is not straight. Let's trace it down. I don't think that this will use scale. Anyway, let's see. This is 5, right? 3 of us is half, is 5, right? So as you move from 55 to 40, this will move from 5 to 6 to what? 5. So the change here will be what? 1 mole. The change here will be what? 1 what? Mole. 1 mole. This and this is what? 1 mole. But there's something they wrote here. They told us the change here is 1 mole. 1 mole. 1 mole will be what? Deposited. But there's something they wrote it. They told us that find the amount of solute deposited when 200 cm of solution is cooled. So the volume of the solution that was cooled was what? 200 what? cm. Are we together? Now 200 cm cube now that was cooled. So 1 mole in 1 mole deposited out of the 200 what? cm cube. True of us. Now what will be this 200 cm cube? This 200 cm cube now, if we move it to the dm cube, what will it give us?
If you move it to
If you move 200 cm cube to dm cube, what will give us?
0.02.
If 1 cm cube is 200, 1 cm cube, 1 dm cube is 1000 cm cube.
0.02.
1 dm cube.
0.2.
0. What? 2. 1 dm cube is what?
1000 cm.
So 200 is what?
0.2.
0.2 dm cube. What they ask is the amount, not the solubility. I've tried to look at this, but the scale on this past question is not how I wish I can get the original past question that has graph. The graph itself. This thing is not that this thing. I don't know how to go about this now. Maybe I'll try to search. This is 2011 JAM question 11. Maybe I'll try to get the original past question and see how this is, how it appeared there. Okay, let me try something else. Let me still use what you did here. Try something else. We got here to be what? We got the upper 55 degrees Celsius. We got it to be what?
6.
This thing doesn't. Good. Let me use paper. Paper will give me some. Let me use edge of the paper. It will give me something better. Paper that are not shifted. Has not shifted. I don't know why. I used to hear people write this, but what happened? Let me use the edge of this paper. Come and see what you are doing. Let me use the edge of this paper and see what you can get. At least I believe it will give us something better. If this is half, right? We got this one, right? Let's try this side. Is this 6?
Yes.
Is this right?
Yes.
Then, so that 55 degrees Celsius correspond to what? 6 moles. Now let's trace 40. I think 40. We take this second line, not the dotted line. Let's see what we get. Let's see where we are using the line, not the dotted line.
5.
Here is what? Is it 5? Is 5. Okay? Yeah? So that is it's actually what? 1 mole, right? The difference is what? 1 mole. So the 55 degrees Celsius correspond to what? 6 moles, right? While 40 degrees Celsius correspond to what? 5 moles. Now let's find the solubility at each of these points and see what we get. After we now do the subtraction, let's see what you can get. Now, let's use the format we used in that last question we saw. I'm not complicating. Let's use the same format and see what we can get. Now, you know what? At least I can let me clean this one. This one is not giving us what we are looking for. Let's use that format and see what we can get. Huh? Okay. Okay, I'll use that one to dry. Now, take a look at this one. This thing now. Let's use that format you used in that first one we did last week. Now here, at 55 degrees Celsius, right? It contains 6 moles, right? Right? In what? 200 what? True of us. Now, but at what? 40 degrees Celsius, it now contains what? 5 moles. In the same what?
200 cm cube.
The solubility becomes 5 moles in 200 cm cube. But here, it was 6 moles in what? 200 was cm cube. So actually, the solubility what? Decreased. True of us. Actually, the solubility what? Decreased. Now let's see what is the amount now that will be what? That will be what? That will come out. is what? 6 moles minus 5 moles is what? 1 mole. 1 moles. Okay. Now, what actually is right now is what? 6 moles here, 5 moles here. As we move from 55 distance, 55 degrees Celsius to okay. So 6 moles here, 5 moles here, 1 mole is deposited. After solving everything I've solved, it's telling me 1 mole is deposited. Is that what you got? What did you get?
I went and did only for 55. I don't know.
How? And got what? And got what? Huh? After everything,
I don't solve it inside now.
Okay.
I solve it.
After everything, this is still give me 1 mole. I don't know where they got the option 0.2 mole. The answer according to them is 0.2 mole. But I don't know where they got it from. This thing keeps telling me 1 mole, 1 mole, 1 mole. Because it cooled from 6 when it was 6 moles in 20 down to when it was, and it became what? 5 moles. So what came out of the solution should be what? 1 mole. I don't know where they got that 0.2 mole. Unless there are some things in that question they didn't capture. Unless there are some things they didn't capture in that question. It doesn't make sense to me. It doesn't make sense to me. At this junction, I don't know what else to solve in this thing. I have some reservations on this question. It's either the equation is not correct, or the curve has issue, because this is the only way you can solve this thing, because you know the number of moles, you trace the number of moles present in that torus cm cube at a particular temperature, and trace the one of still remaining in the what solution, because others will do what to come out as what solid. True of us, the remaining one in the solution is 5 mole per se, based on the diagram, based on the curve, and we are getting what 5 mole minus 6 mole. What it is the same concentration, the same, everything is the same number. Everything is the volume of solution is the same thing. Is that not saying if the solubility, how do you do that? Okay, let's just solve it now. Let's find the solubility in each of them and subtract it and see what we get. Okay? Now let's see what we can get. The solubility is 6 moles in DM. If we change this thing to DM cube is what? 0.2 what? DM cube. Now what's your solubility now? 6 divided by what? What's the answer? DM cube. Do 6 divided by do you understand what we did?
Yes.
Because 30 watts
30 moles per DM.
mole per what?
DM.
DM cube. 6 divided by 0.2, right?
Yes.
At 55 degrees Celsius, it was what? 30 mole per watt. That's the what? Solubility, right?
Yes.
Let's try this step this way. If this doesn't work, then this question is wrong. I'll find the solubility of this one and keep. Find the solubility at this temperature and keep. Subtract the 2 what? Solubilities. Am I communicating? Subtract the 2 solubilities, then move the DM cube back to what? CM cube, and know how many moles will be in that. Move the DM cube back to what? CM cube, and know how many 200 CM cube. Sorry, and know how many moles will be in the what? 200 CM cube. If this one doesn't work, then there's a problem with the what? The diagram. I need to go and look for the what? The correct, the original past question to know how the diagram look like. or whether the question is complete or not. Let's solve it first and see. Now, we change to the same cube to dm cube. We got what? 0.2 dm cube. Now, the solubility at 40 cm cube is what? 5 moles, right? Divided by what? 0.2 dm. What's the answer?
25 mole per dm.
Huh?
25 mole.
dm is what? 25 mole per what? dm cube. Now let's subtract the solubility and see what we get. 30 minus what? 25 is what? 5 what? Mole per what? dm cube. But remember, this is what? dm cube. Let's move this dm cube to cm cube so we can get 200 cm cube. Okay? Let's move this dm cube to cm cube. If you move the dm cube to cm cube, it's going to 5 mole over 1000 cm cube, right? Yes. Right? So divide, okay, simply say 5 moles in what? 1000 what? cm cube. Right? What this means that there are what? 5 moles of where? In what? 1000 cm cube. If there are 5 moles in 1000 cm cube, how many moles will be in what? 200 cm cube. X is now equal to what? Cross multiply, we have what? 5 moles, right? Times what? 200 cm cube over what? 1000 what? cm cube. It's still 1. It's still what? 1. So there's a problem somewhere. It's either the question is not complete, or there's error in the scaling of that thing. I'm not completing. The scale of that thing has a problem. But if we use the scale of what we measure from the plot, the answer is what? 1 mole. But do you understand how to solve it?
Yes.
That is the basic thing, to know how to what. Have you seen that I took it the other way and I still got what? 1 mole. So this is how to solve it. We use the scale and got this, and got it 1 mole per dm cube. If I'm able to see the original, I will check the other parts of the paper. Let me see whether the scale in there is better. Then maybe in our next class, remind me, I will bring the other parts of the paper. We will check it and see whether the scale are the same thing or not. But for now, the most important is that you now understand how to solve such what? Question. This is what's called solubility curve. Solubility what? Curve. This question has to do with this equation of solubility what? Curve. How to trace the curve and solve question in it. Okay? That's what this question is all about. Any question? Any question? All right. See you next time.